A while back I read an article by Bill Gates that said electric trucks will never be suitable for long-haul transportation, and it got me thinking about how feasible the Tesla semi-truck is for different applications, and I ended up falling down a rabbit hole of exploring all the concerns I've seen people raise across the internet. Just as a disclaimer, I'm not a truck driver and definitely don't have answers on all of the topics, but hopefully this video will provide some new information and get you thinking. And I'd be interested to hear your opinions in the comments below. The key challenges I want to talk about are cost, the ability to charge, the range, and the weight. But before that, I just want to mention some other side points I've seen posted too. The first of which says that due to the weight of the truck, it would be unable to stop as the regenerative braking from the motors wouldn't be enough. However, all of the vehicles on the road that can regeneratively brake also have to have conventional brakes to stop as well, so this wouldn't be a problem. Also, I saw people mention the central driving position and lack of sleeper cabin. I've personally never driven a centrally positioned vehicle, but I hear it's great for visibility, apart from when larger vehicle is in front of you and you want to overtake onto oncoming traffic, which I expect wouldn't happen too often in a Tesla semi-truck. Tesla representatives also did mention to Mashables that they're considering a sleeper cab, but I imagine the lack of it indicates the market the Tesla semi-truck is currently going after. The first key challenge is the cost of the semi-truck, both for Tesla to produce and for the consumers to buy. The main costs that relate to the Tesla Semi come from the purchase price and the cost of the electricity for fuel. For the purchase price, the main question on a lot of people's minds is how such a large and expensive battery will still enable Tesla to sell the Semi at a competitive price. The current prices are $150,000 for the 300-mile model and $180,000 for the 500-mile model. Using Tesla's figure of 2 kilowatt hours per mile, this means the batteries will have capacities of roughly 600 kilowatt hours and 1000 kilowatt hours. If we take estimates that it currently costs Tesla around $120 per kilowatt hour, this means the battery would cost around $72,000 and $120,000 respectively. This relates to 48% and 67% of the total vehicle costs, much higher than the average for electric vehicles in 2018, which was just 25%. This does make me question whether Tesla could sell the Semi for a profit, or actually just break even. However, this is not the full story. After Tesla's battery day, it is clear that there are many improvements on the way to reduce the costs per kilowatt hour, with predictions of reducing the price by 56%. It is hard to say when these cost reductions will happen, but predictions are that the price will drop below $100 per kilowatt hour by 2023, which would greatly improve the business case. It's practically impossible for me to know the exact finances for the Semi, but this makes it look like the margins will be very tight, if they exist at all. However, we know Tesla isn't afraid to absorb sustained losses to get a larger market share and eventually turn a profit. Despite these cost challenges on Tesla's side, they expect the cost per mile for consumers to be 17% less than an equivalent diesel truck. And that's not considering the further cost reductions possible from platooning. However, this is assuming an electricity cost of just 7 cents per kilowatt hour, compared to the 28 cents per kilowatt hour at a standard supercharger, and around 12 cents per kilowatt hour for domestic use. So how can Tesla promise such low prices? Well, 7 cents per kilowatt hour is actually a bit higher than the wholesale price of electricity. That is the price at which utility providers buy and sell energy. In America, the wholesale price is around 4.5 cents per kilowatt hour, enabling possible profits for Tesla and an additional revenue stream. With Tesla recently becoming a utility supplier in the UK, this seems like part of their plan. And even if Tesla lose money on energy for charging, it is unlikely to be as much as when they offered free supercharging to early adopters of their passenger cars. Overall, it looks like the finances for Tesla will be tight, but this will inevitably improve as they reduce battery costs and increase market share. The next topic is electricity supply, and specifically whether the grid could handle the load of charging multiple semi-trucks. This is a huge topic and you could easily dedicate a whole YouTube channel to it, but let's try and have a brief look. Going off Elon's statement that the Semi could charge by 80% in 30 minutes, it means 800 kilowatt hours could be charged, or 1.6 megawatt hours in 1 hour. If we say for argument's sake, 3 Semis are charging together, this would require around 5 megawatts of power. This would be equivalent to 20 Tesla passenger cars charging on the 250 kilowatt V3 charging network, which doesn't sound so unrealistic. I don't personally think getting the electricity to the charging station will be the problem, as grid connections for much larger systems are done regularly, such as for wind turbines and solar farms. However, always making sure there is actually enough electricity to supply the chargers may be. This is especially true if more and more electric trucks are on the road and you need to charge a lot more than 3 at a time, which will inevitably happen. This really comes down to the ability to generate electricity, which could be increased with more power plants. Though these would be expensive, may often be underutilized, and if using fossil fuels, would likely be bad for the environment. One solution is the use of energy storage to enable the energy demand to be smoothed out, so there aren't large spikes that put pressure on the electricity supply. One option for this is the use of large batteries, potentially positioned at the charging stations. And if more of the energy generation comes from renewables like wind and solar, the need for storage grows even larger. Unfortunately, these solutions do have significant costs, and it's a very complex topic, but more and more solutions are emerging and will definitely be a topic for more videos. However, power plants likely still have more than enough free capacity to generate electricity during the demands of the Tesla semi-truck and other electric vehicles. So although this will become an increasing problem, I don't see it immediately impacting the rollout of the Tesla semi-truck. Now onto one of the most discussed issues, the range. For reference, trucks in the same class as the Tesla Semi, Class 8, generally have ranges of around 1,000 miles, which is double the longest range Tesla. Though 500 miles of range for the Tesla is when it's fully laden. It is currently quoted as 620 miles unladen, with test drivers saying that it regularly goes further than the 500 miles during use. Though Elon Musk has recently stated that they want to reach 620 miles range even when the Tesla semi-truck is at full capacity. But the real question is, how practical is a 500 mile range semi-truck? Well, research from the US Department of Transport show that around 90% of trucking journeys are less than 500 miles, and about 80% are less than 250 miles, which means the Tesla Semi would be able to recharge at the end of the journey in a lot of situations. Additionally, in many parts of the US, truck drivers have to take compulsory breaks of 30 minutes after a maximum of 8 hours continuous driving. If the megachargers can deliver 400 miles of range in these 30 minutes, it means a truck driver averaging 50 miles per hour over an 8-hour period would only just run out of charge by the time they have to have a break anyway. Now, in reality, it is unlikely a truck driver could perfectly synchronize these breaks, and charging stations could have queues. But mandatory breaks could definitely be used to minimize the time waiting for charging. However, if the operating cost of a Tesla semi-truck is much cheaper, this added inconvenience may be okay, as it almost always comes down to the economics in the end. Though I expect the Tesla Semi to be mainly used for the sub 500 mile journeys, especially when considering the current lack of a sleeper cabin. Another point on this is the effect of cold weather, as this can significantly reduce the range of electric vehicles due to the higher resistances within the battery that reduce efficiency. But I expect there will be a powerful battery heater within the Semi that will warm up the batteries before long journeys to maximize the range. We can see how much energy would be required to warm up the battery with the following equation, which uses the mass, specific heat capacity, which is a measure of how hard it is to warm something up, and the temperature change required. To estimate the weight of the battery, let's assume after the battery day announcements that Tesla can achieve a 20% increase in the pack level gravimetric energy density from the one in the Tesla Model 3. This results in 184 watt-hours per kilogram, meaning the 300-mile battery would weigh around 3,300 kilograms, and the 500-mile battery would weigh around 5,200 kilograms. Also, the specific heat capacity of lithium-ion batteries is around 1,000 joules per kilowatt Kelvin, which means if we want to increase the battery temperature by, say, 15 degrees Celsius, it would require around 50 million joules for the 300-mile battery pack and 78 million joules for the 500-mile battery pack, which equates to 14 kilowatt hours and 22 kilowatt hours respectively, which in comparison to the 600 kilowatt hour and 1 megawatt hour battery packs is not much at all, and it's unlikely this would be drained directly from the battery. Instead, these could be heated before the semi-truck leaves the depot. And finally, the weight. We've already calculated the batteries will likely weigh around 3,300 kilograms and 5,200 kilograms. So what effect will this have on the Semi's practicality? Firstly, let's see how much heavier the Tesla Semi will be versus a diesel truck. Figures online for the weight of a diesel truck powertrain vary a bit, but my estimates put it at around 2,400 kilograms or 5,200 pounds. And for the 500 mile range Tesla, assuming the motors, transmission and other electronics weigh around 300 kilograms, the powertrain will weigh in the region of 5,500 kilograms, or 3,100 kilograms heavier than a conventional diesel truck. Meaning, due to weight restrictions, the Tesla Semi would have a maximum cargo capacity 3.1 tons less than a conventional truck. But does this matter? In some scenarios it definitely will, but I would argue this won't actually be as much of a problem as it may appear. The reason I say this is because trucks often carry less than their maximum allowable load, which is a total weight of 36,300 kilograms or 80,000 pounds. The reason for this is sometimes because the cargo volume is filled before the maximum weight is reached. Research by Oak Ridge National Laboratory shows this, where the vast majority of trucks on the road were below the maximum limit. This means that if an extra 3.1 tons or 6,800 pounds was added to the trucks shown, only trucks weighing over 73,200 pounds would be unable to continue operating, which is only a small fraction. Another example of this that might be easier to visualize can be drawn from looking at this picture of a semi-truck precariously transporting 9 Tesla Model 3s. Let's round up and say each of these cars weigh 1,900 kilograms each. That gives a total cargo weight of 17,100 kilograms. A conventional diesel truck with a trailer weighs around 16,000 kilograms, and we know the Tesla Semi will likely weigh around 3,100 kilograms more than this. So, by adding these all together, we can estimate that a Tesla Semi doing the same job would weigh around 36,200 kilograms, or 79,600 pounds, which is still less than the maximum allowable weight, even if only just. And let's face it, electric cars aren't exactly the lightest thing in the world. So, while I expect there to be some situations where the extra weight will matter, I think this will be a lot less of a problem than it may first seem. And the cost saving potential for companies and truckers will make the Tesla Semi a very attractive vehicle to add to a company's fleet. Thanks for watching this video, and now to quickly summarise some of the points. Firstly, I'd be interested to see what Tesla's profit margins are and how they improve into the future with increased market share and cheaper batteries. I also don't think stress on the grid is going to be a problem initially. However, I think more storage systems are going to have to come into play as more electric vehicles and trucks are on the road to smooth out those demand peaks. And this is especially true with increased renewables. I think the range seems more than enough for most applications. And the lack of a sleeper cabin makes me think that Tesla aren't yet pitching at the really long range market. And although I think the extra weight will impact a small number of journeys, it seems like the vast majority are limited on space rather than weight. Also, there are other ways that Tesla might save weight, in the construction of the truck or by using the batteries as structural components like they spoke about at Battery Day. Also, this video has been a very long time in the making because I've been so busy with work, but I'm hoping that in 2021 there's going to be a lot more frequent videos, so make sure you're subscribed for those. Also, I recently saw a video by a guy called Oliver that touched on some similar topics as this video. I'll leave the link to that and his channel below because I think you guys might be interested in some of his content. But that's all for this video. Thank you very much for over 27,000 subscribers. It's absolutely crazy and I'm excited to see what 2021 brings to the channel. I'll see you in the next video.